You've probably heard about this before, but we always need to simplify our fractions. So, the reason why we simplify is that if we look at these two, 32 out of 64 or 1/2, which one looks a lot nicer? Which one looks like you can understand it better right away? And I would say that you can understand 1/2 immediately, whereas you may have to think about 32 out of 64 and realize it's the same thing as 1/2, but it just looks a lot uglier. So let's prove this. Let's prove that 32 out of 64 is the same as 1/2. Well, what we need to do is to divide the numerator and the denominator by the same factor. And to make our work a lot easier, we always want to divide by the greatest common factor. So that means I need to find the largest factor that's the same for 32 and 64. And one way to do that is to make a factor tree. 32 is 4 times 8, 4 is 2 and 2, 8 is 4 times 2, and then that 4 is another 2 times 2. 64 is 8 times 8, and then 4 times 2, and another 4 times 2, and then this 4, 2, and 2, and this 4, 2 times 2. So we got to look at what's the same. This 2 and this 2 match, so the GCF is equal to 2 times this another 2 that matches, 2 times another 2 that matches, so that's another 2 times another 2 that matches, times one last 2 that matches. So I'm running out of space, so this would really be 2 to the 5th. And if you multiply that out, you'll see that's the same as 32. So we want to divide the numerator by 32 and the bottom, the denominator, by 32. And 32 divided by 32 is 1. 64 divided by 32 is 2. It's the same as 1/2. Here, let's try an easier one with a visual representation. Hopefully you can look at this and come up with the fraction right away, 6 out of 8. But that is not in simplest form. The simplest form would actually be, if we change this a little bit, equal to 1, 2, 3 red ones out of 4. That's how we would do it visually. If we want to do it mathematically, we would divide the numerator and the denominator by 2. 2 is the GCF. It goes into 6 and into 8. 6 divided by 2 is 3. 8 divided by 2 is 4. Let's try another one. Let's make a factor tree for 18 and a factor tree for 20. And when you get good at this, you probably won't need to make the factor trees. But you can look at 18, that's going to be 2 times 9, and 9 is 3 times 3. And I really should be circling my prime factors. 20 is 4 times 5, and 4 is 2 times 2. And now we're looking at what is the same for both of them, and they both have a 2 and nothing else. So divide the numerator by 2 and the denominator by 2. So 18 out of 20 is the exact same amount as 9/10. Here's another one, 7 out of 15. If I make my factor tree, that's going to be 7 and 15. 15 is easy, that's 3 times 5. 7 is prime all by itself, meaning that the GCF is 1. If I divide this 7 and the 15 by 1, they're going to stay the same. That means that this one is already finished. It's already in simplest form. One last one, 18 out of 30. So make my factor tree for 18 and a factor tree for 30. 18 is 2 times 9. 9 is 3 times 3. 30 is 3 times 10, and 10 is 2 times 5. So we can see that there's a 2 in both of them. So the GCF equals 2. And there's a 3 in both of them, times 3. And there's nothing else the same, so the GCF is 6. So we divide numerator and denominator by 6. 18 divided by 6 is 3. 30 divided by 6 is 5. So 18 out of 30 is the exact same amount as 3/5. Now, when we do problems in math, we always check to see if we need to simplify and simplify our fractions. It makes everything look a lot nicer.